Hi geometry students. In this video I'm going to be introducing a totally new area of study in mathematics called trigonometry. This is something you might have heard about before. It comes up and it'll come up every single year for a while in the next few math courses, and we kind of will start in geometry and we'll expand on it in the next through algebra 2 and pre-cal, and we're going to even use it in calculus. So it's a really kind of interesting, totally different topic. Just to kind of clarify a couple things in the worksheet that didn't quite copy is C, we're saying C is equal to 2, A is equal to 1, B is equal to the square root of 3. This is the square root. So just kind of clean this up a little. So to kind of get into this idea of trigonometry, we're going to start with something that we already have studied, which is special right triangles and similar triangles, right? We have 3 different 30, 60, 90 triangles with different sizes. And the idea is we're going to start by kind of exploring what are the different ratios of different sides in each of these triangles. Just to kind of, so the idea is we're going to fill in this table, and I'm actually going to have you pause the video in a moment to try to fill in the table on your own and then press play to see how I filled it in. But we just kind of clarify a couple of things. So when you say the leg opposite the 30-degree angle, I'll do the first one for you. So the ratio of the lengths of the leg opposite the 30-degree angle to the hypotenuse in each of the triangles. So in ABC, my hypotenuse is the side opposite the right angle. So if I go from my right angle straight across, that's my hypotenuse. And the side opposite the 30-degree angle is if I go straight from the 30-degree angle across the triangle, I get to A. So the leg opposite in this one would be side A, and I'd want to do a ratio of side A to the hypotenuse, side C. So in this case, that would be a ratio of 1 to 2. Okay, so that's all we're doing. So let me just clarify then what the adjacent leg is. So the adjacent leg is this, adjacent means next to. So if we have the opposite leg, then this other leg B would be the adjacent leg because it's directly next to the 30-degree angle and it's not the hypotenuse. So we have the opposite over here and the adjacent over there. So that means the adjacent to the 30-degree angle would be side B divided, and we're comparing that to the hypotenuse C. So that would be root 3 over 2. So I'm going to have you pause the video, fill in the rest of the table, and then press play again once you have it filled in. Okay, so at this point, if you don't already have your table filled in, you should. I'm going to run through and finish this out. So the leg opposite the 30-degree angle to the leg adjacent would be A to B, which would be 1 over root 3. And then I'm just going to run down and do the ratios for the other ones. So in DEF, we had a ratio of 2 to 4 here, which is really 1 to 2. Here we had 2 root 3 over 4, which is really, if I simplify, root 3 over 2. Here I had 2 over 2 root 3, which is 1 over root 3. And in my last column, I'm going to have 3 over 6, which is 1/2. 3 root 3 over 6, which is root 3 over 2. And 3 over 3 root 3, which is 1/3, 1 over root 3. Okay, so if you didn't already realize, we see going across each row that the ratios are all the same. So within each of the similar triangles, if I compare the opposite leg to the hypotenuse, then that's going to be the same for all the 30, 60, 90 triangles, no matter what size. Same for adjacent to hypotenuse and same for opposite to adjacent. Now if we think about it, it makes sense that these ratios are all the same because these are all similar triangles. So the ratios of their sides should all be equal if they are similar, right? So I'm just going to write a quick note. This makes sense, or I'll say it makes sense that the ratios are all the same because these are similar triangles. And if you're not sure they're similar, just think about it like this. They all have a right angle, and they all have a 30-degree angle. So we know they're similar by AA theorem. Okay, so trigonometry is basically formalizing these different ratios into 3 different what we call trig ratios. So we call them, you may have heard these words before, the words sine, cosine, and tangent, and these are our trig ratios, and they are exactly the ratios we just worked out above. So the idea is that sine of any angle should always be the same within a right triangle. So that ratio of the opposite to the hypotenuse should always be the same. So I'm just going to kind of write this out for you guys. So remember that if we're talking about angle A, then the side across from the right angle is the hypotenuse. And then the side across the right angle would be the opposite leg. And then the side like directly next to it that's not the hypotenuse would be the adjacent leg. So now to set up the ratios, the idea is sine will always be opposite over hypotenuse. Cosine will always be adjacent leg over the hypotenuse. And tangent will always be the opposite leg over the adjacent leg. And you may say to yourself, like, what's the point of formalizing the, like, just calling these proportions that I know are always the same, these different trig values? And we're going to see that it allows us to solve a whole bunch of problems that we weren't able to solve before. So the idea is if we know what the angle is, then we know what the ratio is, then we could solve for one of the legs. And one quick kind of mnemonic device that we use to help us, we're going to need to kind of remember which is which. So to help you memorize, we say sine, we'll use that, sorry, I'm writing over here. So we say sine for S is opposite over hypotenuse, so we call it so. Cosine, C, is adjacent over hypotenuse, so we call it ca. And then tangent, T, is opposite over adjacent, so we call it toa. And then you might have, I don't know if you've heard this before, but we would say SOHCAHTOA. And if you can remember SOHCAHTOA, then you can remember which trig ratio is which, okay? And this is something we're going to need to memorize. Okay, so now we're going to flip over to the back and see how we can use these trig ratios to do some problem solving. So the first example is just kind of, can we set up the ratios for a given triangle? So it says find all 3 trig ratios for angle A and for angle B. So we can do it for either angle in the triangle. And the only thing is in this diagram right now, I don't currently know what my hypotenuse is, but I do know my legs are 5 and 12. And if you remember your Pythagorean triples, then this C value must be 13. You could have also gotten there by doing the Pythagorean theorem. Okay, so let's start by thinking about angle A. So for angle A, we have our opposite side, our opposite leg is going to be CB, or the value 5. Our adjacent leg, the leg next to it, is the 12. And then C is my hypotenuse. So if I'm setting up sine of A, cosine of A, and tan of A, then I'm thinking about opposite, hypotenuse, and adjacent. One quick thing I forgot to mention is these 3 letters are the abbreviations for sine, cosine, and tangent. You'll also see those values on your calculators because your calculator actually knows all of the trig ratios and can actually spit them out for you. Okay, so the idea is sine would be, in this case, opposite over hypotenuse, 5 over 13. Cosine would be adjacent over hypotenuse, 12 over 13. And tangent would be opposite over adjacent, 5 over 12. So now we can do the same exact thing, but with angle B. The only thing is that now what was the opposite side is now going to be the adjacent side to B, and what was the adjacent side to A is now the opposite side to B. Okay, so basically those 2 legs are switching what we are thinking about them as if we are thinking about a different angle. So I'm can do sine B, cosine B, tan B. And so sine, remember, so ka toa. So you can always kind of write that at the top of your paper and keep referring back to it until you have it memorized. But sine of B now, opposite over hypotenuse, should be 12 over 13. Cosine of B is now adjacent over hypotenuse, so that should be 5 over 13. And then tangent is opposite over adjacent, so it should be 12 over 5. So one thing you might notice is that cosine of A is the same as sine of B. Sine of A is the same as cosine of B because the opposite and adjacent sides switched. That'll always be true for any triangle. Okay, so at this point in time, I'd like you to pause the video and see if you can do the exact same thing for this different triangle. Can you come up with all the trig ratios for angle A and for angle B? Remember that the thing to be most careful about is what's your opposite side and what's your adjacent side. So now, in the second example problem, I'm going to use the fact that if we know what a trig ratio is, so it's telling us that tangent of 40 degrees is this value 0.8391, then we could solve to find an unknown side in the triangle. And this actually helps us solve so many different types of problems. So the idea is let me set up the trig ratio involving tan 40. So that would be tan of 40 is equal to, well, I know tan is TOA, so I want to do from 40 degrees the opposite side over the adjacent side. So in this case, that would be H over 50. Now notice I just set up an equation, and there's only one variable in it. The only variable in it is H. Tan of 40 is a number that I know, right? So I can actually take this decimal and plug it in for tan of 40, and if I didn't give it to you, you could do that on your calculator, or sometimes we'll have like a table that gives you different trig values. So I can replace tan 40 with that value, and then how do I finish solving for H? I would have to get rid of the 50 in the denominator by multiplying both sides by 50, and using a calculator we can get 50 times 0.8391 is 41.95 for H. So what's the meaning of that? That would be the height of this tree. And it says to the nearest foot, so I'm going to round that to 42 feet. And the cool thing about this is it might be hard as a person kind of like standing on the ground. It's hard to know what the height of this tree is, but it's easier to measure how far I am. So think about what sides are you going to need to set equal to sine 40 in order to solve for H. And we will check in about these U-try problems when we get to class. Have a good weekend.